Hello everyone, and welcome back to the Winter Data Meetup. I hope you all enjoyed the thoughtful talks and discussions we had so far. Meet Kseniya Kochava, a lead data quality engineer at EPAM. In her talk, Kseniya will guide us through the secrets of project success and the crucial role data quality engineering plays. Now, before we dive into our next session, I'd like to take a moment to ask for your support in helping us grow our community and recognize the speakers. Firstly, if you're enjoying the content we're providing and want to stay updated on future events and talks, please consider hitting the like and subscribe buttons below the video. Now, for something a bit special. In the video description below, you will find the link to the talk page where you can provide feedback to the talk, give speaker a badge, and rate the session. Your feedback is incredibly valuable to us as it helps us to improve future events and also provides recognition for our speakers' hard work and dedication. Throughout the talk, if you have any burning questions or insights you'd like to share, don't hesitate to type them into the chat box. Our team will be monitoring the chat closely and we will collect all your questions to discuss with the speaker after the presentation. And now, let's welcome our speaker to share her valuable knowledge for us. Ksenia, the stage is yours.
Thank you, Lisa. Hopefully you can hear me. Hello, everyone, and thank you for joining this evening. I know it's getting really late in some locations, so I appreciate your effort and your joining here. This presentation is called Perfecting Data, Unveiling the Art of Data Quality Engineering, and the focus would be absolutely on the second part, data quality engineering. We will talk about data quality engineering as a discipline to practice and to learn, as a service that is offered to a client, and as integral part of any data project, and of data quality engineers as specialists and as a project role. But first, let me introduce myself. My name is Kseniya Kochava, and for the past 10 years, I've been working in EPAM Systems. For the 6 years, I've been working in functional testing department, and for past 4 years in data quality engineering department. I'm also a resource manager in data quality unit and a coordinator for training programs to DQE Poland, and that includes retraining from functional testing and other disciplines into the data quality engineering. Now, for the past years that I've worked on different projects, I faced many situations when the data quality engineering role and responsibility is not really clear to the project, and the role that these specialists play can seem sometimes ambiguous. So, over the course of the next 40-30 minutes, we will talk about the following items. First, I'd like to focus on the general entry into data and what capabilities and challenges it brings to us. Then we will talk a little bit about the types of data projects, looking from their perspective and from the areas that they address. We'll talk about the data quality engineering targets, scope of work of data quality engineering team, and last but not least, we'll talk about data quality engineers and some of the perspectives. At the end, we'll have a short Q&A session where you will be able to answer some of the questions, and hopefully we will be able to guide you in the correct way. So without further ado, I'd like to focus on the what is data these days and what data capabilities bring to us. Almost every single application this day is gathering data. It is all around us, and its usage is very widespread in different spheres. Take science, healthcare, finance, and marketing. Data analysis and predictions based on that are used for early detection of skin cancer, for the predictions of the efficiency and profitability of different marketing campaigns. It is used for the financial forecasting, for the many areas and aspects of our life. One of the fun examples of marriage between the data analysis and data predictions and entertainment would be the viewer's favorite show, House of Cards, US version. When the whole process started, Netflix was considering relaunching the House of Cards, which was a British show back then, and they have gathered analysis and identified what would be the key metrics to ensure the show's success. And it turns out that the combination of this particular director, actor, and in this setting and this idea was predicted to bring in the audience and show high ratings for the show. It turned out to be absolutely true, and this just once again proves that data can do anything and even predicts our likes and something that we will watch in future. However, with the increased capabilities, we have increased challenges. Poor data quality would be probably one of them, if not the most important one, because duplicated, erroneous, incorrect data, poorly validated data can cause revenue lossage to the company. According to the Monte Carlo statistics for the 2023, it was established that among the companies that rely heavily on data analysis, the cost of incorrect data assumption and fixing it, as well as reloading the data, can sometimes be up till 10 to 30% of data revenue, which is incredibly important because the purpose of the data analysis would be to ensure the cost efficiency and correct budgeting rather than losing the data. Since, as I mentioned earlier, the data collection is becoming more and more widespread, and as well as data storage, more data regulations are being introduced by the governments. We can talk about the most well-known, probably GDPR, but there are also different PIPL regulations in China, POPIA in South Africa. There are also Children's Protection Act in the United States, as well as many other legislations that are aimed at monitoring how the data is stored, used, and the retention policies. So making sure to address those regulations and staying compliant to those policies is key for any business. It has already been addressed by some of the industry giants that failing to meet the GDPR Section 83, which is one of the most strictest section, can result in 2 to 4% fines for the whole turnover of the fiscal year of the company, which can be millions and millions of dollars. So the importance of these regulations cannot be underestimated. The next item is system scalability. On average, for the company, there are around 642 tables across data lake or lake warehouse and different environments. It means that with every single day, all the predictions that were made for the 2024, for the 2023 has been proven wrong because the volume of the data has been increasing significantly and it is exceeding our expectations, which means that all systems have to address that need, adjust to it, and it also requires data quality in this component, in this one. On top of that, we have high cost of maintenance and support of this whole infrastructure and of data. Again, around 80% of time of data engineer is spent on updating, maintaining, and assuring of quality of the pipeline, which is critical. And obviously, this is something that should be taken care of and be addressed in the first item. Not to mention the fact that among the data storage, if we take an example of 642 tables, there is a very, very high probability that some of this data is just stale, it's not used, but the company and the customer is still paying for that, for the maintenance and support of these items. These are just a few of the many, many challenges that are facing for the data projects and the companies that are relying heavily on them. So before we actually move on to the data quality as a discipline, I would like to focus a little bit more on the data projects themselves and what needs emerge from them. So this particular distribution of the data projects is very subjective because it is mostly based on the some of the components that are used within that. And within it, I will mostly focus on how this what data quality aspects are included into this particular data project or data aspect of the project. So approximately 1/3 of all projects are related to the migration or remodeling. The instances and examples of this remodeling can be different. It can be a migration from on-premise solution to cloud or to multi-cloud. It can be upgrades, introduction of new policies, many items for and reasons for systems to upgrade and remodel. It seems crucial for when doing this process to ensure that the data flow is uninterrupted and the migration occurs smoothly. Sometimes it can be as simple as lift and shift, but in some cases it requires significant structural changes. And data quality would be the person who would be responsible for ensuring that the previous configuration works as expected and that the new configuration matches with the same requirements and has addresses the same needs. We check the compatibility between those two systems, ensure that the data was brought over correctly, that all the processes were set up, there are no issues with connection. So basically, data migration and remodeling would be probably 1/3 of the reasons why data quality of the work of the data quality engineers. If we talk about the next one, the projects with the machine learning and with the AI are becoming increasingly popular these days. It is probably one of the most challenging tasks for the data quality discipline, because as of now, the data quality engineering still has limited capabilities in terms of providing some testing for those types of projects. But they're also the ones which will be growing the fastest in the future, and we can already see that there is a significant increase for data quality. So around 20% of all new data quality positions that are being created are looking for experience specifically with AI or machine learning testing. Now, the aspects of this testing can also seem tricky, because breaking down it into different components can be challenging, or not as easy as, for example, with pipeline testing. So you would need to ensure that there is a correct validation at the input data, at the output data, comparison of the results, the usage of different frameworks for measuring the accuracy and the training capabilities of the model can also be tricky. Right now, it still takes a lot of research to find and identify the useful solutions. But these projects, they will continue to grow, and for with the increased usage of them, there will be an increased demand for better quality and better visibility of how they actually work. If the previous one was a relatively new one and requires still a lot of investigation, for the data storage and the pipelines projects, everything seems to be rather clear as day. So we do have a system that has data entries and data outputs. We have data flow between it. And data quality is basically responsible for ensuring different quality gates at every single step of the way of how the data flows, to ensure that we do not have any issues that would prevent it. It also includes monitoring pipeline health and ensuring that if we don't have the data, it can be generated and the pipeline would be tested anyway. Similarly, data quality is responsible for the data storage, how it is managed, and all that would be included in this data storage and pipeline testing projects. Last but definitely not least are the BI reports. So business intelligence is becoming crucial in decision making and in all the processes around business. I like the saying that data without analysis is just data, but with analysis, it is information. This is the information that is used by the businesses to make decisions in terms of their perspectives. It provides good visibility of the processes that are going on with business and with the market. So it is becoming more and more crucial, and the usage of different types of BI tools is also increasing. So from the data quality perspective, an engineer would be necessary to ensure that these BI reports actually represent correct information, that all transformations that are happening within these reports are correct and lead to the expected results. We would also be responsible for the so-called interface part of it, to make sure that everything works according to the expectations and to the some graphical design principles that would be applied to that. Having discussed some of the projects, I'd like to focus on these three areas of the data quality, or so-called targets. So I have identified and categorized them more into process, data, and system. With the data quality, it is impossible to focus on just one of them to ensure a good product. Perfecting data means looking at data quality from different aspects and ensuring that everything works together and is combined. We'll start with the first one, which is system. And under system, I understand different components. It can be a classical data warehouse, data lakes, data lake house. We can look at the granularity of the tables, of the objects. Data quality engineers would be responsible for testing all that, making sure that, for example, in terms of the migrations, we have systems that correspond to the requirements, that there are no data losses, there are no interruptions in the processes. Working with the data as a system is also obviously talking about the different environments. We will be looking at some additional tools like data catalog or data, and as well as data lineage, to ensure that there is a clear and consistent way how data flows and we can see all the dependencies. We will be also talking about the testing and creating some documentation, as well as setting alerts and warnings, as well as reflecting correct state of the data. It is also a target of data quality testing. And last but not least, we also have BI reports. I have mentioned already previously what would be the focus of BI reports testing, this is also one of the items that is becoming for the data quality targets. So basically, system would be the element that is under test, and in our case, it would be a complex one and the whole combination of what makes the project. The next one would be the process. Now, for the process, we will be looking at all the steps that data takes while it flows through our system from point A to point B. It includes testing like on a very high level. If we're talking about some ETL testing, it could be some inbound checks, ensuring that we have a consistent pipeline, that that all the mappings are tested, that we have correct mappings to the tables. We can provide test data to run through those pipelines. We also check that all the data source connections are established correctly, that we get files in the correct format as FTP, that we have established an error notification process in case something goes wrong. So this would be the sort of inbound checks of how we receive the data and making sure that we have some quality gates at the entrance of this data. The next one would be the transformation checks. They includes the next steps the data would take. It would be the loading into some tables, going through the layers, aggregations, joins, and building other views how this data will be transformed. And last but not least, we would have the outbound data checks, would be looking at some of the extracts that are used for this generated using the data, as well as some BI extracts generation, and testing this whole process from beginning to end can be a one-time effort, but rather a lasting one, because we need to continuously make sure that the pipeline run consistently and that they produce expected results. So this would be also a regression testing involved in this particular discipline. And last but not least, you can have all those processes and systems established and configured correctly, but you will still be receiving the data. A decision would be made based on that prognosis or data analysis. But it would turn out that a few weeks ago, one of the SFTP vendors has introduced some different configuration, and it resulted in the data quality issue. Let's say that some currency was applied incorrectly, and you're receiving values in different currency now instead of what was expected. So basically, decision making when it comes to the errors or incorrect data is completely faulty at this point, and it means that you can always, of course, you can always rely on the intuition of your data analysis, but most likely you would need something more concrete. In this case, it would be a set of data quality dimensions and data observability tools. And this is how we monitor the most important part would be the data. So for the data quality dimensions, it has become a very widespread notion. So I believe a lot of people are familiar with what would be the data quality dimensions, such as timeliness, consistency, completeness, uniqueness, accuracy, and validity. They have different names in different classifications, but the ultimate goal is ensuring that you receive the correct data type, that your data is fresh, that it corresponds to your expectations in terms of the ranges of the data you receive, that if there is a valid values configuration, you're also looking at that. Additionally, you can be looking at some and increasingly companies are more interested in looking some complex analysis like anomalies detection, some pattern detection, to make sure that you have, for example, some postal address in the correct format, that all the phone numbers in the correct format being provided. You can also look at the distribution of the data. So say the company has always been receiving around 30% from US, but as of recently it has dropped to 2%, and there was no particular reason for that, which indicates to us that there might be a data quality issue. And obviously a high profile in this case would be a data protection and data retention policy, which means ensuring that the personal data is treated correctly and according to all the regulations, that it's not stored somewhere explicitly, that you have a mechanism of data retention and masking PI information. So all those data quality dimensions and many others can be monitored in some custom framework using the data profiling tools, and the abundance of these data profiling tools is growing. So as of recently, I would select this BigEye, Calibra, Informatica, Experian. There are many, many others, and they all although they all present more or less same goals, they have slight differences in calculating those metrics, and they present different set of tools for the end users. Some of them are looking for more experienced users, and some offer a very explicit user interface for you to be able to create the rules and easily set them up without SQL knowledge. Additionally, some of them have ML capabilities to be able to predict and look back at the history of the data. And this is basically the set of these DQ tools and accelerators. It's very high. And we also have additional capabilities in terms of creating test data when the pipeline testing is required. And again, all these items will be available and are explicitly reviewed and described in the presentation about data quality service offering that was done by Olga Melnikova, and you can take a look at that. A link would be provided. So with the abundance of these data quality tools and accelerators, the data quality engineers would be also the people who would be responsible for looking through those tools, selecting the needs, and advising on the best one. From looking just one of the aspects like data, it is impossible to understand what would be the quality of the product and whether it is reliable. It takes a detailed testing and the configuration of all those three aspects to make sure that your data process is correct. Having said that, I'd like to switch to the data quality engineer responsibilities and what would be the areas of focus. So obviously the pipeline testing, whether it's a manual process or an automated, is one of the responsibilities. Monitoring pipeline health and running test data through it. The next part would be the BI reports validation. From the BI reports item, we can look at the different types of testing. We can look at the functional testing, at some of the aspects of non-functional testing, like, for example, what would be the performance of the dashboard, how it is loading. We can also look at the UI aspect and even usability aspect, how convenient it is to use. So basically all the interactions that the business implements within the BI reports. We are looking at the data profiling and data observability tools implementation and application on particular projects. So the data quality engineer would be looking at a different set of tools based on the project needs, whether we're looking for an open source or a paid version, or we're looking for a tool with the ML capabilities. Do we need to set up alerts? Are we interested in having a separate report based on that in some dashboard? We will be looking at some of the connections that can be provided, for example, to Tableau or Airflow. How can we set up with other tools for the visibility of the data status? Um, Ultimately, all of the positions that are looking for the data quality engineer specify that working with requirements would be a priority number one, because a lot of business requirements would need a thorough testing, as well as the mapping validation. So that's also one of the responsibilities. Data quality engineers are also doing a root cause analysis, an extensive root cause analysis to take a look at the data lineage to see where the issue occurred, how it can be fixed, and they address this with the testing. Ultimately, we have documentation, test artifacts creation. It can be a data migration testing plan. It can be, in general, a data quality engineering approach, a framework that would be used, and also data quality reports with the analysis of the data quality metrics. And last but not least, we have machine learning models testing. Again, as mentioned earlier, it's becoming increasingly popular among the projects, as well as AI testing. So to address all those responsibilities, the set of tools that a data quality engineer should possess is very approximately built in here. You can look at the different areas. It would be a scripting language and analytical dashboards. Again, a set of tools can differentiate between the projects. I would say the most popular would be Tableau, Power BI, Looker, Domo for many projects. In terms of scripting language, the absolute leaders would be the SQL and Python, with increasingly popular Spark, Scala, PySpark, sometimes Java. At the large scale data tools, again, the list for this particular item, we can select different platforms as well as data storage tools and data manipulation tools. So we'll be looking at the Hadoop, at the Kafka, Spark, integration with Snowflakes, and looking at such platforms as Databricks, which is also becoming very popular. And for the testing aspect, the experience in requirements testing is a must, looking at the functional, non-functional testing types and understanding the artifacts that should be created for the testing process. Obviously, there are more skills that are required that are not mentioned here. It could be understanding of source version control, as well as experience with different set of tools, generation of data, familiarity with theory of how the data warehouse works, and many others. Um, Based on all that, we can look at the directions where the data is going and what would be the demand for the data quality as well as for this whole data development. More companies these days are looking at the real-time data, which means that they're moving away from a more classical data warehouse and the pipelines that can take too long to compute and to be able to deliver to the real results. It would mean that the data quality would have to become more proactive than reactive, and it would be looking more at data in real time while setting up the alerts proactively and making sure that the end users already know the state of the data by the time they are using it. So there will be less delay, there would be less traditional data warehousing approaches, and obviously it would require and adjustability from the data quality discipline as well. In terms of the detection and data quality development, there will be an increased demand in data detection of data anomalies with the machine learning. A lot of data observability tools are already trying to integrate that because it is not just about meeting the standard data quality dimensions. It is also about being able to detect those data anomalies and reflect and look at back at some of the data inputs to make sure that the data is correct and consistent. Also, these data anomalies detection can be very useful when it comes to different segments of finance reporting and helping to predict some of the expected values as well as to adjust to some external factors. So, for example, to be able to measure the supply and demand changes based on the holidays, based on in general number of sales within this particular year, but this particular season. This is something that is very hard to detect in with manual testing, but is increasingly popular with machine learning. So detection of data anomalies will become a direction in which the industry would be going increasingly. And last but not least, many businesses these days are going from the centralized data to more decentralized while treating the data as the products and distributing it between different teams. Each team would have an implemented set of data governance, and basically the data quality will be required at each single one of them. It will be necessary to monitor and to make sure that there won't be any data silos at this point. So any direction that the data spheres and projects will take, data quality would become an essential part of that. And with the increased usage of data, we will definitely see more regulations and more capabilities for the data quality discipline to develop. So hopefully within these presentations, you were able to understand better what would be the data quality engineering on the project and what areas it is overlooking, looking at. After this session, obviously the presentation would be shared with you, and as well as additional links and useful materials. There were different topics already made on the data quality discipline, so feel free to look through them. And now we have some time for questions and answers, if you have any. So Lisa, I would probably pass the
Yeah,
word to you.
yeah. Thank you, Ksenia, for the presentation. We have questions, and the first question is: how does the role of a data quality engineer differ from a data engineer?
Thank you. So I would say that the data quality and data engineer do have something in common in the sense that they will be both developing certain tools and frameworks. But data engineer would obviously be working on the data flows establishment, while data quality engineers are more focused on the framework to measure the quality of the data. So if a data engineer is implementing a pipeline of how to get data from point A to point C, a data quality would be testing how this pipeline works and creating, for example, an automating set of tests that ensure that this pipeline works as expected. It can be a backend work, or it can be something with the implementation in, for example, with so basically with the backend and with the dashboard that would be displaying the results of this run. So basically, yeah, a solution in itself. But testing is in huge parts of the data quality aspect in this case.
Thank you. The next question. How does a data quality engineer collaborate with other teams within an organization, such as data science, engineering, and business units?
Um, Data quality is in close collaborations with all of those people because first of all, for the data quality, for the data engineering, data quality provides feedback on issues that might occur or some suggested improvements in terms of the implementation based on general analysis of the system. So for example, there might be some inconsistencies between again, I'm talking a lot about ETL, but it would be a perfect example. So if you have noticed a difference in implementations based on your knowledge of the system and the pipelines, you can also suggest some improvements. Working together with business analysts is crucial because it helps you not only to measure the technical implementation, but understand the business requirements for it. So it can be a schedule of how often data is updated, some rules how it should be displayed. It can be a general understanding of the demand of the business and what business expects from this particular data. Was
So,
there anyone else?
yeah, does it mean that data quality engineers need to have business analyst skills and knowledge?
Absolutely, because you would definitely need that for the mappings. You would definitely need that for understanding what is. So basically, part of any successful engineer is understanding the domain and the business that they work in, and business analysts, they are probably the best people to show that. So there is a lot of learning and a lot of interaction between the two of them. You simply sometimes it's very hard to predict whether certain feeds work as expected if you do not understand what is the purpose of these feeds and what are they doing.
Yeah, it makes sense. So the next question. Um, what does the career path look like for a data quality engineer?
It's a good one. So first of all, data quality engineer is a relatively new discipline. So these days we're noticing that more and more people are switching to it from different disciplines because obviously, as compared to, so for example, functional testing, it's more new and it has developed as a direction of its own. So data quality engineering can be a target. If looking from other aspects, but also in terms of the data quality engineer itself, I would say that it gives you a perfect intro into the data projects. You can obviously develop into different spheres after that. You can look at the data engineering path, you can look at into more data analyst part, so many directions. But as a data quality engineer, it is an increasingly competitive sphere. It requires constant growing. So
Mm.
it's impossible to be familiar with one tool set and work on different projects. You always have to grow and develop. So yeah, I would say that this path is continuous learning and continuous growing and developing your skill sets up to the point when you become a person who could be responsible for the whole process set up on your project.
Okay, and there is a question. Is it required to have knowledge, experience in coding to work as a data quality? What do you think?
For the most of the majority, for the majority of the projects, it would be required, yes, because, like I said, one of the although more and more projects are using additional frameworks and tools that can have a rather friendly interface. For example, if we're talking about data observability tools, many of them offer a dashboard and interface where you can configure a whole set of data quality rules without using code. But to make sure that to create a really extensive framework to be able to operate with data and to compare the data sets, coding skills would be a definite must.
Okay, and so there are many ready DQ tools today, like Great Expectations, DQ. Why do DQs need to create custom data quality framework?
There are indeed a lot of data quality solutions that are kind of reflecting on what data quality expectations are. So definitely DQ is one of the first ones that comes to mind because it's an open source solution. However, those tools, they are also a limited in a sense of metrics
Mhm.
because they're the metrics that they apply, they are very general in the sense of the data observability tools, and data quality is not only about those particular metrics. So for data quality, you might be looking at some of the very particular business rules. They have to be implemented in the custom ways. Not to mention the fact that there is a lot of different criteria, what comes into mind when you are assessing the project's data. So it can be some of them can be configured in data quality tools, like how often do you check the data, what would be the deltas, what would be the set of parameterizations that can be used. But many of those items, which are on the business side, like source files, validations, error notifications, uh, pipeline health monitoring and testing data, it is still seems to be very custom and something that is done by the data quality specialist on the projects better. Because from what I've personally seen, all the data quality solutions, they offer a very standard configuration that is not often easy to adjust to particular project needs.
Okay, thank you. The next question. How has the demand for data quality engineers changed in the past few years and your forecast of demand?
I would say that there would be a growing demand for a more technically skilled data quality engineer. So there would be definitely a shift into usage of the data. So there would be a shift into usage more data observability platforms from the data quality perspective, and there would be also an increased demand for people who understand machine learning and can provide proper testing of that. So I would not say that. There would be a significant change in the number of increase or decrease in demand, but there will be a shift in terms of what kind of specialists are required and what would be their skill set.
Okay, thank you. Next question. Should data engineers learn how to create data quality gates?
Um, of course, it can be beneficial for the project, that is for sure, because creating data quality gates can be built in into the pipeline to make sure that, for example, if we have received incorrect data or it is ill formatted, it doesn't meet the first criteria, like the acceptance criteria for this particular pipeline, and you can already establish some flags that would not allow this data to go further and corrupt other data sets. So that would be a must. The difference here would be like the crucial reason why it's basically the same as the question, why can't developers test their own code? They can.
Yeah.
It's just it's two different perspectives and two different points of views. Data quality engineers are aimed at looking at some flaws and systems under test. So data quality have the perspective how to look at the pipeline. From data engineering side, it might not always be so visible what would be the defect, where would be the defects and the items. So it would require a background in understanding.
Okay, Kseniya is here. Thank you. So the next question. Could you give advice how to increase data quality visibility? Data can be valid or non-valid. What else can be shown? I guess maybe it's about
So
some,
again,
reports.
there is
Mhm.
I would like to draw attention that it's not only about data, it is also about some systems that so we can be monitoring, for example, at earlier stages of the pipeline health, looking how the pipelines ran, it will already immediately indicate to you that there is some issue. So that could become one of the metrics as well. For the data validity, validity is a very broad definition. So there is a set of metrics that is used. So they were mentioned on the previous slide, like ensuring that data is fresh, that it contains the correct data types, correct patterns. All that can be used as those metrics, and in general assessment of this data in terms of the metric can then be displayed as the dashboard, where you would be able to see that, for example, this particular table has met all the checks and it is, for example, in the green state. If you see that there was some rule violation, like uniqueness or granularity is incorrect on the table, it would have a red flag and alert. It would immediately indicate to you. So I would say that it is important to understand what is the demand, what is the most critical data because again, high volume, it is impossible to be looking at every single data set at once, establishing the most critical items and setting up the checks as well as the display of the results. It can be in some test result reports or in the dashboard or in some alerts that are set up, but basically it would provide you a status of your data at the moment.
Okay, understood. Thank you. The next question is an interesting one. Have you tried Soda GPT? Does it replace data quality team?
I have not tried the Soda GPT, but I have recently reviewed some of the Soda data observability tools. And again, I would say that it is still uh, requires a lot of input as well as additional data quality work, like for example making sure that if you receive some spikes in data, some items that are considered as data anomalies, they all require attention. They need to be looked at if it should be triaged, if it's really a defect, because you always need to provide like an additional feedback and background based on whether it was really an issue, whether it's really an anomaly in data or it was something that was expected. So I would say that it is good as an additional tool, but it won't fully replace the data quality.
Okay, and maybe the related question. Um, have you used ChatGPT and how it can make your work easier and more efficient? Maybe some life hacks or tips?
Again, ChatGPT would be a very useful learning tool. I guess I believe we're all using that. But ChatGPT should also be treated as a product that should be tested and sometimes can have it flaws. So, for example, I would not rely fully on ChatGPT to provide an assessment of projects to establish some set of rules, because the information can be outdated and it's not always accurate. Or so basically, yeah, it can provide us a lot of defects that also need some attention and testing.
I guess maybe we should close our session for today. So we hope you found this talk insightful and inspiring. In the video description below, you will find a link to the talk page where you can provide feedback on this talk, give speaker a badge, rate the session, and download the presentation. Thank you very much, Ksenia, for coming, and to all who watched this video for your participation, engagement, and support. We look forward to seeing you at our next sessions. Until then, stay curious, stay inspired, and keep exploring the exciting world of data. And goodbye.